Hello, today I'll be showing you how to make a 3D print fin in TinkerCAD and proceed to 3D print it. So first of all, you would want to click join out to create an account on TinkerCAD and allow you to join. Now it's gonna ask for you to put in your country, which is Canada, your birth date, so something like this, probably 2004, and then you would click next. Then it'll ask for your email, so you can just type in your school email, which is your student number. So for mine, it's 708756 at pdsb.net, and that's your student email. Password can be whatever you like, and all you need to do is click agree and then create the account. Once you create the account, you want to head over to your Gmail. So for my TinkerCAD account, I used this email, so I would open it in Gmail, and it'll send you an email called like a verification email. You want to open that and just click the link, and it'll open. It'll redirect you, and since you verified your account now, it's your account now. So once you do that, you want to just you're probably already logged you in. So let me just sign in with my account right now. So if I sign in, it'll bring you to this dashboard, and if it's not on this dashboard, just click this logo. It'll send you back to this dashboard because it'll probably give you an introduction or something. So once you're over here, you just click on create new design, and once you're on create new design, you have a plane to work with. So if you right click, like the right button of your mouse, you can move the plane around and view your model from different perspectives, which allows you to like see different angles. And if you use your scroll wheel, rolling it up zooms it in, and rolling it out zooms it out, pretty obvious. And if you click on your scroll wheel, it shifts the plane, so like I can move it from left to right or up and down, but it won't change the angle I view it from. So that's middle mouse click, so just clicking on your scroll wheel. So once you get like flow with these controls, you can also use this to help you just go precisely on it. Just yeah, so it's not that hard. And then right on the right, you have your objects, which you're gonna use to create a more complex shape that will allow you to make your fin. So for example, let's drag this box on, right? So this box right now, you can see that the measurement is 20 millimeters by 20 millimeters. Hitting this corner will allow you to make it any size you want, and then hitting these will just restrain what side is making it longer. So it's kind of like, Google Slides, like the text box and the shapes. But now since there's a third dimension, you have this little axis right here. It controls how thick or high your object is. So you can just drag it longer and drag it shorter. And if you want to move the object physically higher, you just take this black arrow thing and you can just move it higher. And if you're below the object, like below the plane, so let me just move it down again. If you're below the plane, it would put these two things below so you can see. And if you want to just move the object around, it's just a drag. So once you play around with the shapes and stuff, I'm gonna show you how to like actually make, for example, a fin. So the most basic shape is like a parallelogram, or like for example in the example Mr. Heine gave to us. So we're in the for the foam fins. So first of all, because we don't have a parallelogram shape in here, what you can do is you can split it into two shapes, like in math class. Well, this isn't really math, but like you want to take the triangle and you probably want to shorten it because it's probably too thick, to like around 5 millimeters. That's a good thickness for it. And then you want to expand it to whatever size you want. But since you need the surface that you're gonna glue the fin to be around 3.5 inches, or around 8.7 centimeters, you want to just get it so it's 8.7 centimeters. So since I'm holding here, I can just tell from this measurement. So 8.7 centimeters. Yep. And that's your fin, like the generalized shape. So that's one side. And then you want to click Control C and then Control V to copy and paste. And once you paste it, you want to just use this little rotate thing and rotate it 90 degrees. Here's a trick. if you move a cursor outside of the little blue ring, it's going by degrees, and if you move it in, it snaps into every, I think, like 12.5 degrees. So now once you rotated it upside down, you want to drag it so that it lines up with the other triangle, and now you have the basic shape of your fin. Now, to create some more complex shapes, I'm going to show you next. Just first, um, so because right now these two are separate shapes, right? You can click on both of them. So click Shift and click on one and click on the other one, and you can click Group, which will group the shape into just one big shape. Okay, you won't be able to like edit the options anymore, but like you really don't. So to ungroup it, you can just click ungroup, and I'll just do that again. So we just need a group right now because that makes the shape a lot easier to view. So now if you want to create like a beveled edge, right? What you can do is you can take a roof again, and this time, since we know that the thickness of the triangle is 5 millimeters, and we're going to connect the bottom of this roof to that bevel, we can make it also 5 millimeters. Now, so you can make it as sharp as you want, so I'm just going to do probably 8 millimeters. And then you just want to make it pretty long, and you want to rotate it so that it's around uh, 45 degrees. And then you want to just, so you see, if you rotate it to 45 degrees and it doesn't like fit the length of your shape, then just Control Z so it's back to the vertical. Because if you enlarge it like the other way, it might distort the shape a bit. So you want to just make it a bit longer. And then now just go to rotate 45 degrees. And now you can line it up with your shape. And then you can take this rotate, or my bad. So I guess you have to rotate this first by 90 degrees. So just that's a simple 90 degrees. I just typed it in. And then you want to rotate this by 45 degrees, which allows you to now place the object almost perfectly on the other fin. Now if you look closely, it's a bit tall, so you can just take this and drag it down to about the 0 point. And now because there's still a little gap, you can just move along and you can view if there's still a gap, and there is. So you can just move the fin into the shape a bit if you want, which is okay because this little overhang won't matter too much, but it'll still give you that beveled edge which you want, because it affects the aerodynamics by a lot. Like, so once you connect the shape, or it's near connected, so I'm just trying to adjust it so it looks okay. Which this is fine. So now you see we have the beveled edge, but we have these parts sticking out, which is obviously something we don't want. Simple way to solve this is to just get a box. Okay, so this box, it's gonna act as your like cutting tool in this in TinkerCAD. So if you click on hole, this basically means, so if I put this here, this basically means that the area that the box is taking up in won't get printed. So basically, we want to use this box to be able to cut this out by extending it across the whole fin. And if we click on the box, hold Shift, and click on the bevel, and we click Group, it just removes the bevel and makes it a flat surface, a clean flat surface for us to work on. And you can also continue with this one right here. You can just take the box, or the box with the hole, or you can just do it like take the regular box and click hole. Doesn't really matter, they're all the same. You just line it up, drag it my bad, drag it this way, and then just click on this and group it with this. So now you have a fin that's lined up here with a beveled edge, and because we've increased the length of the fin with I mean, it doesn't really matter, but if it affects you, because now if we just, because this was 8.7 millimeters ish, and we added another like centimeter to this, it'll be a bit longer, but you can still glue it by just attaching glue to this area. So it's not gonna be a big deal, but if you want to, you can shrink down the triangle so that it all fits in that perfect cardboard tab. But if it sticks out, it will make a big difference. So now you have the basic general shape of your fin. This is the most basic shape. You can just take, if you like to, you can just take both shapes, hold shift and click on both of them, and then just group them so they're one whole shape. And if you want to hollow it out, right, this part is where it gets complicated. Well, it's not really the most complicated thing, but if you want to hollow it out, I recommend you to use triangles because they're the strongest shape. And then you can just or not to, don't use the roof, use the wedge, I would say, and just rotate it on a 90-degree angle and just make a hole. Now you can just place some of these wedges right in here, and if you see, I'm just gonna try to save as much space as possible by just placing these wedges randomly. Now it'll take a bit of time for you to like get this precisely with this side, unless you just want to fill in the, the the fin randomly, because you're trying to minimize the materials used to make the fin lighter, and also it makes it better for flight and saves more material on the 3D printer. So you just keep rotating it around until you get around this stage, and maybe you can do one more. So let me try. Rotate it, and yeah, we can do one more. So once you have this type of basic shape done, you can just click on your fin, click on all 6 of these objects, just group it again, and it'll just cut all of the holes out. And you see how these things bridge? It'll become stronger. And some other examples is if you want to put your name on the fin, you can also do that. So for example, I'll put my name as Andy, and I can, oh, my bad, I can put my name as Andy, and I can move my name up here, make it a bit smaller, and then I can make it as a whole, and then drag it through. And now it's through the whole shape, so I can just click this, click on my name, click group right here, and then just it groups it, and there we go. My name's engraved in the shape. If you want to do more complex designs, you can also take a roof instead of a um like wedge, and it'll give you a rounded tip for your fin, which is supposedly better, but it doesn't really matter. It's gonna affect sliding performances, but I'm just giving you all the options you want. So you can literally use any of these shapes for putting the holes in. I don't recommend I recommend like these straight top shapes, not like these rounded tips, because then you can just put equal holes throughout the whole thing. And in the end, it'll make your fin lighter. It won't like reduce the durability because it'll still be pretty strong because it's plastic. You can just put vinyl over it. But yeah, that's basically how to make a basic fin shape. And once you're um, done this fin shape, you can take a ruler to just make sure you have all of the measurements. So we can see right here that it's around 87 millimeters tall, and till here it's like halfway point, it's around like 90 millimeters long. Just do the math right here. So it'd be like 90, 100 millimeters long. Won't be that bad. And then after you're done, you can uh, just check in with Mr. Hynek or me to just verify your design in case there's something wrong with it that can affect the printer. Like for here, this wouldn't be good because this wouldn't stick onto your component because this is not connected to the rest of the thing. So what you should do is probably take a different font that like that, or you just print the A without the little hole in the middle, which look pretty weird. That's why names aren't recommended the most, but you can still do it. The hole in the D won't show and the A, but it'll be recognizable. It's all your personal preference. But once you're done, you just click export, and then you just click STL, and it'll export it, and you can just save it as a file, and then get a USB, put on the USB, and and you can just transfer it to a different we'll put on a different computer, and then we'll print it'll be printed.